Hi, welcome to another mini lecture on pre-calculus. Today's topic is a word problem involving a sine or cosine function, problem type 2. Okay, let me just remind you of some basic facts we went through last time. Uh, Many physical phenomena follow this kind of sine function. So a times sine of bx plus c plus d. So there are four numbers here and they all mean something to us. Item number one was that the amplitude is absolute value of a. By the way, in all the problems we consider, be considered to be positive for simplicity. If amplitude is a, absolute value of a, the highest point we are going to arrive at is that amplitude plus the midline shift. So we are going to have an item called the maximum that's going to be absolute value of a plus d. The minimum, when we go to the lowest point of this, absolute value is going to be subtracted from d. So the minimum point of the curve is going to be minus absolute value of a plus d. If you want midline of your graph, midline is of course just d itself. Then we had the concept of period. Period is going to be length of time it takes for the function to repeat itself. In these cases, perhaps it makes a lot more sense to use the letter t instead of x to indicate that t is time for us now. Previously, well, just had a generic letter x, but now more often than not we are using letter t to indicate something's changing in time, and the period is the length of time it takes for something to repeat itself, and in this case it's going to be 2 pi over, we assume b is positive, and becomes 2 pi over b. Then an item that's not so emphasized in this set of problems is the shift that we went through is where the 0 goes here, and the shift was minus c over b. We have a new concept which is the frequency or number of cycles per unit of time. Well, how many of these fit in one? So that is 1 over 2 pi over b, which simply simplifies to b over 2 pi. So frequency is simply the fraction that you had for period. You have to turn it upside down and then you will have your frequency. Well, these are the concepts that are being applied to set of word problems. In each case you read it, try to familiarize yourself with the statement of the problem, and then apply these concepts. Let's go take a look at a few cases. So first one, brightness of certain stars can fluctuate over time. Suppose that the brightness of one such star is given by the following function. B of t is 10.6 minus 1.4 sine of 0.14 t. So again, we have here, this whole thing has to be in a parentheses. In this equation, B of t represents the number of magnitude of brightness. So stars come with a certain magnitude brightness, and t is time in days. We want to find the following, and then you want to also round it. Number of cycles of b per day in maximum brightness and the period of b. Maximum, let's go after maximum brightness first. This one is the midline or d that you had in the previous equation. Well, we go up or down by the amplitude. So if I take 10.6 and then go up by, so take absolute value of this thing and therefore go up by 1.4, we get 12, and that's the maximum brightness. So maximum brightness becomes max 12. If for some reason they had asked us for minimum brightness from 10.6, you're going to go down by 1.4, and then of course that's going to get you 9.2, but they don't ask that question here. In case they had asked for minimum, it would have been 9.2. What's the period? Period, we said 2 pi divided by that number, so 2 pi divided by 0.14, and we calculate it and then round it. What's the cycle, number of cycles per day? 1 divided by period. We are asking how many periods fit in one day. 1 divided by that simply makes this fraction to go upside down. So 0.14 and divided by 2 pi, and again you round it. We didn't have any phase shift here to worry about, and pretty much we covered all the bases here. Midline of brightness, it is like the average brightness, like 10.6, and we covered all the bases. As I said, shift doesn't show up in these problems all that often. Another example is a musician is playing a tuba. If she plays a note and holds it for a significant length of time, the air pressure, so this is what we are calculating, air pressure, near the opening of the tuba is modeled by the following functions. So P represents the air pressure. It is measured in Pascal, so you can see that in your physics class perhaps. That's how to measure air pressure. The unit of air pressure. So P of T is this peculiar function 101,326 plus 0.5 times sine of, again, 326.2 T. Okay, what is the maximum air pressure? Maximum air pressure, we start at 101,326. That's the midline, and then if you add 0.5 to it, that is going to become the maximum. So of course that's just the answer. If the minimum air pressure was asked for, it would have been 101,326 minus 0.5, and then what you're supposed to round here is of course nothing to round. Frequency and period. A period is 2 pi divided by that multiple 326.2. Number of cycles per second is 326.2 divided by 2 pi, and again you round it. That is probably all that we need here. Another example, population size of many animal species rise and fall over time. So periodic phenomena can apply to populations. Suppose that the population of certain species can be modeled by the following. Like some data is collected and they fit it to a curve, and perhaps this is what comes out. What is the amplitude? Let me make sure I did not make a mistake on the previous okay, this one is asking for amplitude. Previous one we're asking for maximum minimum. So amplitude is absolute value of this number, 1160. If they ask us for the maximum population, it would have been 3360 plus 1160. If they ask for minimum, it would be, of course, 3360 minus 1160. Period of this thing, again, we need to have a parenthesis here. Period is 2 pi over 0.9. What's the number of cycles per year? It's going to be 0.9 over 2 pi. Okay. Okay, so that was short and sweet. And so remember, frequency in your book here. Sometimes in your physics classes they might give you another definition of frequency. Just notice while it is used locally, b over 2 pi is what we are using here. Just the reciprocal of this one. They go hand in hand. Okay, so until next time, we are almost finished with section 4-5, I guess. We are going to move on to the next section soon. And you want to get ready for some identities and uh, solving triangles that are going to be the last part of trigonometry for the course. Until next time, good luck and God bless.